Greetings, everyone. This is Nate's response to Homework 3, Problem 2, where we are challenged and charged to take a random variable x and convert it to a random variable y with the following specifications: that g of x is equal to the absolute value of x, and that for the interval -1 to 1, x is equal to 0. We basically start out by restating the equation, the density equation that was given, where E is equal to the minus x plus 1, U of x plus 1. And it implies that its distribution function is the quantity 1 minus E to the minus x plus 1 times U to the x plus 1. Okay, given that extracted distribution function, we then apply to the proposed random variable y is equal to 0, and that in doing so, that the probability of x that's less than or minus 1 plus the probability of the random variable x greater than 1 is equal to the probability of x less than or minus 1 plus the probability of x greater than 1. And when we translate this into the corresponding equation, we have f of x, value of minus 1 plus 1 minus the value of the preceding distribution function, equal to 0 plus 1 minus 1 minus e to the minus 1 plus x times the quantity u of 1 plus 1 is equal to e to the minus 2 over the interval 0 to 1. Okay, consequently, the new distribution function for y is determined by the equation f of x of the 2 points of x1 and x2 being over the first derivative of x1 and x2 as described in the equation, and it yields f of x, the quantity minus y, plus f of x, y. This translates into e to the minus y plus 1 times u, the quantity y plus 1, plus e to the minus y plus 1 times u times the quantity y plus 1, which translates into e to the minus 1, e to the y plus e to the minus y. Okay, basically, what we have now is the density function for the new y random variable, and with the corresponding constraints e to the minus 2 delta y for y equal to 0, e to the minus 1, the quantity e to the y plus e to the minus y for y greater than 0 and less than 1 and 0 otherwise. And now for the remainder of the presentation. Continuing homework assignment 3, problem 2. Over the interval from 0 to 1, the distribution function for the y random variable is equal to minus infinity to y, the distribution function alpha d alpha, which breaks down into the distribution function plus alpha, equaling e to the minus 2 plus the integral from 0 to y of f of y alpha d alpha, which is equal to e to the minus 2 plus e to the minus 1 from 0 to y of e to the alpha plus e to the minus alpha d alpha. Okay, which in turn is equal to e to the minus 2 plus e to the minus 1, the parentheses, e to the alpha evaluated from 0 to y minus e to the minus 1 evaluated from 0 to y, which is equal to e to the minus 2 plus e to the minus 1, parentheses, e to the y minus 1 minus e to the minus y minus 1. In summary, therefore, it's e to the minus 2 plus e to the minus 1, the parentheses, e to the y minus e to the minus y. And this is for all y greater than or equal to 1. And certainly the corresponding variable y's distribution function equals 1. And then we can see in the two diagrams where one we have the new random variables density function, approaching 1 as a limitation, and its corresponding distribution function with y going from e to a minus 2 to 1. Thank you very much.